Right. These two graphs, I really enjoy these two graphs. It is comparing the modern Holocene to the period during the last glacial maximum when climate was warming. So going from that glacial period during the Ice Age to the interglacial, the warm period we have now, and showing where that carbon dioxide went. Right. So during the last glacial maximum, the global surface ocean was 3 to 5 degrees Celsius cooler than today. And we know by looking at the amount of carbon in the ocean from the ice core records, the solubility of carbon dioxide increases at colder temperatures. So the colder the water, the more carbon dioxide it can hold. And this is because when water heats up, the atoms start to vibrate and shift farther away from each other, and that allows the gas to escape. But as long as the water is cold, those atoms are closer together, they're not vibrating as quickly, they can hold that gas in the water. So we know by looking at the end of the last glacial maximum that as water warms up, it can hold less carbon. And I ask you, is there a feedback loop here? Or actually, as I have written it, is there a feedback loop here? Yes, there is a feedback loop, right? Because the warmer it gets, the less carbon the ocean can hold. So the more carbon is going to stay in the atmosphere, the warmer it gets. So the less carbon the ocean can hold, so the more carbon stays in the atmosphere, and so on and so on and so on. And we are stuck in this positive feedback loop where it gets hotter and hotter and hotter. Okay. Now, we also know by looking at these graphs that higher rates of dust or iron, so looking at this iron fertilization, stimulates marine productivity, right? Lowering atmospheric carbon dioxide. So the more dust there is in the atmosphere, the more iron sinks into our oceans, and iron is a nutrient for marine organisms. That's going to increase productivity in the ocean of phytoplankton, and that's actually going to draw down that carbon dioxide into the ocean as they photosynthesize. So we have to ask ourselves, what type of climate would produce more dust? Well, probably a really hot climate, right? Dust is going to be produced where there's lots of evaporation in places that have lots of droughts, and we know that that's happening due to climate change. So we are moving into a time with more and more dust, just like we saw during the end of the last glacial maximum. So again, is there a feedback loop here? Right, we're getting warmer, there's more and more dust. Dust, we know, stimulates marine productivity, lowering carbon dioxide. So yeah, we're getting a feedback loop here, and this one's a good one. This is a negative feedback loop. Because the warmer it gets, the more dust there is, the more iron there is in the ocean, the more productive the oceans are, the more carbon dioxide is drawn down due to photosynthesis, and that's actually going to cool the climate. So we are causing a negative feedback loop there.